Okay, so our next presenter is Kristin Carlson. Kristin is an assistant professor in the Arts Technology program at Illinois State University. She explores the role that computation plays in embodied creative processes. So her background is in movement, technical theater, important, not theory, interaction design and programming. So, she's sort of working across choreography, media, performance, and she also publishes in the field of cognitive science, computing, electronic art. So I always find that interesting. So many of us are writers at the same time, trying to find answers to questions that parallel what we do in our practices. Okay, Kristin.
Great, thank you. Let's see here. So I think I can do, okay, great. So my background is really in movement and somatic practices and choreography. So, but I came to technology early on in my practice because I was really fascinated by the way that technology and thinking through procedural code made me reconsider my compositional processes. So I've done a lot of, this presentation will kind of flip a little bit of now I'm working in code so much that I'm thinking very much about what is my body experience in terms of what I am emitting and what can be captured by the technology, as well as what is my then receiving process and getting back out of generative works. And let's see here. So just for those who don't know, because I always have to define this, choreography really is a compositional process of the body. It really privileges sensory information and the relationship of the body within an environment and in relationship to other bodies. So sensation and tactility and awareness and expansion is really important in this process. And I think it's really fascinating because that knowledge is really what the decision-making process is in choreography. Dancers and choreographers are making choices based on what they feel, which is really fascinating when we start exploring technology. Yes, and so I'll keep moving through because yes, this is a little small for me to see. But I have to jump into pop culture just for a second here because motion capture is such a big part of movies and video games. Yet we're still not able to really separate, like in video games, they still re-record motion capture data for every single character. They're not using machine learning yet to manipulate or reuse that data just because it's too expensive, whether computationally or financially. But then you'll see, like in Beauty and the Beast here, that the quality of the motion for those characters is really important. And so there's still, this actor has lots of padding and he's wearing, funny things on his feet to give him some additional qualities of movement in his real person that is then we're rigging another character onto in the post-production process. But I find this fascinating because there has been a lot of work that does try to separate the qualities of movement performance. So how you separate, one of the movement frameworks that's used often is called Laban movement analysis, and they talk about effort qualities where you can pull out elements of time and weight and flow and space. And in a way, you're kind of trying to separate what are the forces and the energies of the movement away from the actual space and time position of that body part. And there's been a lot of work in this. We're still not there yet. Movement data, who knew, is really complex and has a lot of parts to it. And when you're gathering things at 260 frames per second, that's a lot of information to crunch. But one of the places I like to go, I'm going to have to turn and read this real quick. But Merce Cunningham is a famous choreographer who's partners with John Cage. And he did a lot of work with technology and has this great quote that I look at some things and say, well, that's impossible for a dancer to do. But if I look long enough, I could think of a way it could be done. Not exactly as it's done on the screen, but it could prompt my eye to see something I've never thought of before. He was quite advanced in his career when in the 90s, someone brought a computer to him that would do some animation of choreography. And he didn't really know how to use a computer at that point, and someone helped him construct these like weird dances on avatars that he then was so fascinated with how he could try and get his dancers to perform those works, because he, you know, again, as choreographers are working from the body and from their environment and any inspirations they can find, this was a totally new perspective. And while choreographers and artists have worked with technological concepts before and procedural ways of thinking, this was a very new thing. So I'm going to separate the last bit a little bit into talking about data recognition as how you're gathering input, which is how we're capturing data from the body. And I'm just going to talk about a couple of projects, but I've been really fascinated with some applied things recently. Like I've been working on a physical therapy project where patients always need more motivation to stay engaged in their rehabilitation process, because it's hard to just do those actions over and over again. But I was surprised when I started talking to physical therapists that they weren't interested in the qualities of the motion at all. They didn't care if you did them fast or slow. They didn't care if you had a lot of tension while you were doing them. As long as you extended and flexed your arms, it was fine. But just from my background in all of this, I think that there's something there to explore. So we've been doing a little bit of work to capture qualities of movement along with the body positions to create a game that patients could play. Although I'm still surprised at what works and what doesn't. So we right now have two games. One is that you're doing arm extensions and flicking. So you're doing short, quick, light movements in order to move through asteroids. But this works great. You'd think that the effort quality part of the qualitative part of this would be challenging. Whereas the next game, you're doing squats. So all you're doing is bending your knees. But I have not gotten this to work yet. After, I think we've collected data from maybe 50 different or more people doing squats and been applying machine learning in order to develop models of this. And so I'm always a little bit surprised at what things work and what things don't. But we have people playing with that. And then we have, so then there's the generation component, and this is the part I've kind of really fallen in love with, mainly because I'll say that this kind of work has come to really strongly out of my choreographic practice, because choreographers have, like most artists, you spend years developing techniques and skills that are based in a large history that you're trying to become very proficient at, as well as developing new ideas and worldviews about how you're going to shift and change those skills in new environments. But it's so easy to fall into your own patterns and develop habits that are really difficult to get out of. And it's one thing artists are always looking for new inspiration, and sometimes you find the right inspiration that'll work you out of those patterns, but sometimes it's a little bit more challenging. So I've done some work designing a system that would help me get out of those patterns. And I found that just providing new inspiration was not enough, that it was really easy to still fall back into patterns, but then, and I thought maybe it's just me, maybe I'm just a weird person, so I'll give it to some other choreographers. But I could give something that would create really weird shapes to a dancer, and they would do a ballet phrase out of this. And I have no idea, how, did you even look at the system? But it's just the way that, depending on whether the information is too foreign to them or the way they choose to interpret it, was really fascinating in a way. So I found through a lot of exploration that I needed to do a system that kind of had two parts. So one is inspiring people to do something new, but the other one is actually trying to pinpoint what are some of those patterns that I wanted to pull back from or inhibit. So, so I worked on kind of having this two-part system that would try and pull back certain patterns so that there was more space to explore the new things. So this kind of manifested in, this is not the prettiest system. We're still using the Carnegie Mellon's mocap model right now. But I've worked with a team that has taken this original dance animation software from the 90s called Dance Forms. We now have an iPad version of it called iDance Forms. Yes, and it's sort of keyframe animation based. So you've got all these little stick figures, and you can poke at different joints and manipulate them and create body positions that way, and then you can animate through them to create phrases. You can also use the camera to capture body positions and then map them onto things. So I started really playing with designing a generative component for this, because for all, this technology has now been around for, over 25 years. And it's really for a choreographer to use it, they really need to focus on, pinpointing joints and designing things on this very detailed level, which is not really how dancers work when they're sensing and moving through their environments and listening to other people. So, so this generative component, still based in the keyframe animation component, but I in my little system of inhibiting some things and pushing other ones, used a genetic algorithm in order to generate different positions based on things that would be asymmetrical, unstable, because instability promotes movement because you can't stay still, unusual joint angles just because it makes people think differently, and kept it limb focused instead of core. And in an earlier version of this, I also included a combination of qualitative effort information as well, where as you're trying to make sense of whatever this is, you're also trying to do it in a way that's quick and strong, which is a lot of information for a dancer. But through this, it works in the way that dancers can generate ideas. They can participate in the function, it's got a parameterized fitness function. So they can, that's all based on Laban. So you can shift, how much extension for the limbs there is, and whether you want movement to happen more on one side of the body or across the body. What did I say there? And so, so it gives all these interesting opportunities for how someone can interpret the data, which still is pretty, as you're looking at this as a static form, which is great as an inspiration. Marie Chouinard has a great piece where she took a book of I think it's ink blots that look very similar to this sort of work, and the whole thing is show an ink blot, someone moves that piece. Next ink blot, someone moves the next piece. So this framing of how to create dance out of inspiration has been used forever. But I think here's an example. Do I need to hit the play button?
Just press
one more time? Okay. Okay, so this is an example of someone developing a phrase based on the animation that they created. And this one was pretty traditional of dancers creating, expecting to create a phrase. This next one was a little bit different in that this dancer was very fascinated with the animation process and the experience of touch, and how her current choreographic process was very much about what it felt like to stroke her arm, and how she could feel both from her arm to her hand and from her hand to her arm, and what that meant as she was moving. And so she was trying to animate that, and she was surprised that it took her 15 frames or something. And it's still, as you see this, it's there's a lot of happening in a very slow amount of time, and then it just the rest of it kind of looks thrown away because it's quick. I think that's basically it. Perfect. Okay, so the last thing I'm just going to wrap up with is then, so we've had a little bit of the recognition of how you're performing and that information is captured in order to control other systems, but then the flip side of how you're generating information that then you can interpret and take and receive that information. So then playing with interaction, there's been a little bit of other work that has played with both of those together. So for example, I'll just say this MViz system. The performer is wearing an accelerometer that is detecting effort qualities. And so that is controlling some of the parameters of a visual system. There's also a Connect that's detecting your body position and changes through space and time. And then there is a LViz, I believe, generated visuals that go along with this that are mapped to various qualities. So it's a very interesting experience to be playing back and forth with, that the expressiveness of your movement is controlling or guiding a particular system, but you're also responding to it in the same way, probably similar to a very nervous system, and that you're both to be both the controller and the receiver, and it is such a fun improvisational place to be, and gives you a lot of space to play. But I'm going to end it there.
A School of Media.